Hello, welcome back to Algebra. Here in this lesson, we're going to cover the concept of writing equations of lines. Now you might say, haven't we been writing equations of lines this whole time? Yeah, of course we have. But what we've done so far is I've introduced standard form of a line, and then we did slope-intercept form of a line, and then we did point-slope form of a line, and we kind of introduced them in little pieces because, I want to teach you about those little pieces, right? Well, now what we're going to do is we're going to use all of those skills together, because in real life what you're going to be given on a test is the teacher is probably going to give you some information, and then they're just going to say, write an equation of a line. They probably won't even tell you to graph the line. They'll just say, here's some information, and I want you to write an equation of a line. And you're going to have to figure out, do I need to use the point-slope form? Do I need to use the slope-intercept form? Do I need to use standard form? And it's going to depend on what the problem really asks you and what they give you, right? So we've taken our graph paper down. We're not going to graph any of these equations. So we're not going to be able to check ourselves by graphing. We're just going to be writing down these equations of lines. So before we actually do our problems, I want to write down the different forms again. So we have the standard form, which was ax plus by is equal to c, and a, b, and c are numbers, right? And then we had slope, intercept. We talked about this a lot. That's y is equal to mx plus b, right? And then we just did the last one. We had the point slope form of the equation of the line, which was what? It was y minus y1 equals m times x minus x1. And what I'm telling you is, when I give you different types of problems, you're going to have to figure out what the correct path is forward. I'm not going to tell you, oh, use the slope-intercept, or I'm not going to tell you, use the point-slope. But the good news is that it's going to be very simple to do these problems after a little while, because it's going to be very obvious what you need to do. The only thing that's going to trip you up is that as we get a little bit farther into these problems here, you're going to have fractions for your slope and fractions for your y-intercept. So when you add things together, you'll have to deal with fractions. So I'm sorry, that's just kind of like the way it is. You're going to have to get good at dealing with fractions. So I'm going to walk you through them here, of course, but if you're weak on that, you need to go back and get really good at adding fractions and things like that. So first problem, and actually let me just say, for all of these problems, what I want you to do is two things. The first thing I want you to write an equation of a line in whatever form you can. And then the second thing is I want you to write all of these lines in standard form. So the path is we're going to write it down however we can. We're using whatever form we can on the board. But then after we get that, we're going to write it in standard form as the very last step. So we're going to give it in two answers. But it's the same line, just expressed in two different ways. So the first problem is, if I tell you that this line goes through the point 2, 3, that's what this capital P means. It means the line goes through this point. And it also has the slope of m equals 1. Write me an equation of the line. So you have to decide what to use, right? Well, you can't use slope-intercept because I don't know the y-intercept. I've just given a point that the line goes through and its slope. So I'm going to have to use the point-slope form. So it'll be y minus y1 equals m times x minus x1. I promise you, you'll get so tired of writing that after a while. But for right now, we're just going to write it. Y minus y1 is 3 is equal to m, which is 1, times x minus x1, which is 2. And then on the right-hand side, we just distribute the 1 in. So all we get is x minus 2. We just distribute and multiply in, and we get x minus 2. And then finally, we move this over to the right-hand side by adding 3. So we'll get x. Now, what's going to happen when you have negative 2 and you add 3? So negative 2 plus 3 is going to give you a positive 1. So you're going to get y is equal to x plus 1, right? So this right here is the slope-intercept form. So you could circle this as the equation of the line that you get from this information, but what I really want you to do is get down to this point, and then as the very final step, I want you to write the equation of the line in standard form. So how do you get this to standard form? All you have to do is take this and manipulate it so that it looks like ax plus by is c. So move the x to the other side by subtracting x. So it'd be y minus x is equal to 1. All I did was subtract x from the right, so it disappears, subtract x from y, and so you get y minus x there. Now typically you want it to be ax plus by is equal to c, so you want to have the x first, right? So let's write it as negative x plus y is equal to 1. Now this technically is standard form. I could circle this as my answer, but it's just a little bit prettier that when you write it at ax plus by is equal to c, that the coefficient of a, or the coefficient of the x term, the a right there, is a positive number. It doesn't have to be, but it just looks a little prettier. So for all of my answers, I don't really want this to be a negative here. I want it to be a positive. So how can I change it so I don't change the line, but make this positive? Well, what I'll do is I'll multiply the whole thing, both sides of the equation, by -1. Remember, any equation, I can do anything I want to both sides as long as I balance it by doing it to both sides. So I don't like this negative. It's not wrong to leave it like that. I just don't like it. So I want to get rid of it. So I'm going to multiply by -1, but when I do that, I have to multiply the whole thing by -1, which means I have to multiply the right by -1. So what I will get at the end of the day is x minus y by multiplying in equals 1. I'll get x minus y, I'm sorry, not 1 on the right. It'll be -1. Because negative times positive there. So this is the standard form. This is the standard form. So for all of these problems in this lesson, that's what we're basically going to do for all of them. What we're going to do is I'm going to give you some information. You're going to have to choose what information you have matches up with what you can do. Then you're going to write down the equation of a line. You're almost always going to get it down to slope-intercept form pretty easily, but I want you to go past that point just for practice and manipulate it down till you get it into standard form. Ax plus by is equal to c, but generally I want this guy to be a positive term, the very first guy. That's going to be the most perfect form. So on a test, if I give you some information or if your teacher says, hey, write me equations of lines, make sure they're in standard form, this is how you do it. And we're going to do that for lots and lots of different situations. So for our next problem, let's go ahead and say that the slope of the line is -1, but it goes through a y-intercept of 2. So notice that this is a different problem because in the first problem I gave you the slope of the line and I told you that it went through a certain point. But in this problem, I'm not giving you that it goes through just any old point. I'm telling you the y-intercept of the line, and I'm also telling you that the slope as well. So when I give you the y-intercept, what you know from this is you know that b is equal to 2. So I have a different set of information. I know the slope and I know the y-intercept, so I don't need to go through this stuff. I'm just going to go through the slope-intercept form. So it's going to be y equals mx plus b. So y equals m is -1 times x plus b, which is 2, right? And it's basically very simple. Y is equal to -x plus 2. So this is the answer to the line. If I just wanted to graph it or something, I would just stop here and I would graph it. But I don't want you to stop here. This is what we call, I'm not even going to write it down. This is slope-intercept form. We all know that, mx plus b. But I want to go down to that and put it in standard form. So let's move the x over here. And by adding it, so we'll have x plus y equals 2. Because I add x here, makes it disappear. I add x over here, bringing it over there. And this is going to be in standard form. Very, very common types of test questions where you're going to be given information and then you're going to have to determine how to write the equation of the line yourself without being told, and then to write it in standard form. Okay? But honestly, if I was going to graph it, I wouldn't even use standard form. I would just use this form up here because it's much easier to graph. Now for our next problem, it's just a line goes through the points 0, 0 and 5, -2. So this one looks a little different because I'm telling you the line goes through 0, 0 and it goes through 5, -2. So if I were going to plot it, I could certainly put those two dots on the graph and I can draw my line. But I've only told you that it goes through those points, and I go over here and I look and I say, well, which one of these can I use? I don't really have anything ready-made that I can then plug into because I'm not given the slope. I'm not given the slope in this guy, but I give you 2 points. And you know, without me telling you, that you can calculate the slope of a line once you know any 2 points on the line. Remember I told you we did a lot of work with calculating slope, and I told you that the first thing you're going to have to do when figuring out lines is you're going to have to know the slope. Well, here I didn't give you the slope, but you have to find it. And then you have to use point-slope form to figure it out. So what we're going to do is we're going to first calculate the slope of this line. So m is equal to delta y over delta x, which, just to refresh your memory, is y2 minus y1 over x2 minus x1. So we're going to go this direction, subtraction-wise. So we'll have negative 2 for y minus this y, which is 0. And then here we'll have 5 minus this x over here, which is 0. So we'll have negative 2 over 5. So the slope is negative 2/5, right? Negative 2/5. Now, I wasn't given the slope, but now I know the slope. And I also know not only 1 point, but I know 2 points. So actually, I have some choices here. I can do lots of things. I'm going to go ahead and use the point slope form of the line, right, which is this one right here, to find it. But the thing is that to use that form of the equation of a line, all you need to know is the slope and a point on the line. But I know 2 points on the line. So you might say, well, which point do I use? Well, the answer is it doesn't matter. You can use either one. You'll get the same answer. In fact, let's do it both ways. Let's say you're going to say y minus y1 equals m times x minus x1. Let's use this point right here. So y minus 0, this is the 0 from here, equals the slope that I know, which is negative 2/5, x minus this 0 right here. All right? So on the left, I just get y. On the right, I just have negative 2/5 x. And then the 0 doesn't matter. When I multiply and distribute in, it gives me 0. So this is, it's not standard form, but it is the equation of the line. I could graph this if I want to. Now let's go over here and do it using this point. So we'll do the same thing. Y minus y1 equals m times x minus x1, where I'm going to use this point. So it would be y minus negative 2 equals the slope, which is negative 2/5, x minus 5, right? Now, what I'm going to have here is y plus 2 is equal to negative, here I have to multiply in. The negative 2/5 will be distributed in negative 2/5 x. And then over here, I'm going to multiply this in. Negative 2/5 times negative 5 is going to give me a positive 2/5 times 5. Make sure you understand that. I've just taken the negative 2/5, I multiply by the negative 5, which is the multiplication, but it becomes positive because negative times negative is positive. But look at what happens on the right-hand side. The 5's cancel because one's in the top and one's in the bottom. So really what you actually have over here is you'll have y plus 2 on the left, negative 2/5 x plus 2 on the right. Now I'm going to subtract 2 from the left, but then I'll also subtract 2 from the right. So really what I will get is y is equal to negative 2/5 x, because I subtract 2 from here, but then I subtract 2 from here and it goes away. You see, I got exactly the same answer for the equation of the line. It doesn't matter what point you use. If you know the slope and you know any point on the line, you will get the one and only equation for that line. So don't stress out if you have 2 points on your line. Now for all the future problems, I'm just going to pick one randomly. Once I calculate the slope, I'll just pick a point and we'll use that one, but it won't matter because you can use any point you want, okay, as long as it's on the line. Now I told you that generally we want to go ahead and write these in standard form. So let's move this over, and in order to do that, it'll be 2/5 x plus y is equal to 0. Okay, 2/5 x plus y is equal to 0. Because I'm going to add the x term to the right, which makes it 0, I'll add the x term to the left and gives you this. Now this technically is in standard form because a, b, and c are numbers, but it's just a little more pretty. I just generally don't want a fraction sitting out here, just like I don't really want negative numbers, like I didn't want this negative number here. So to make it beautiful, right, you want to write it in standard form, ax plus by equals c, and you generally don't want a, the first leading thing here, you don't want it to be negative, and you just generally don't want it to be a fraction, right? It's not really wrong, you just don't want to. So how do I get rid of the 2/5 if I want to get rid of it? Well, let me rewrite this. 2/5 x plus y equals 0. What could I multiply this left-hand term by, or let me just look at the x. What can I multiply this by so that I will just have a whole number in the answer? If I multiply this by 5, the 5's would cancel and I would be left with 2. That would give me a whole number. I like that instead of the fraction, right? But if I multiply by 5 on the left, I have to multiply by 5 on the right. So what's going to happen is when I multiply the 5 by this term, the 5's will cancel. I'll just have 2x left over. When I multiply the 5 by y, I'll have 5y. And on the right, it's still going to be 0. Now it turns out that this is a standard form equation of a line, and it just looks a little bit prettier than this one. This is also a standard form equation of a line as well. AX plus BY is C, just like this is AX plus BY is C, and then you say, well, what's the difference? Well, there's really no difference. It's just that we don't generally like to have negative numbers in the front here. We just generally don't like to look at fractions in the front. So we try to kill them when we can, and this is what I'm teaching you to do. But this equation of a line in standard form is functionally exactly the same as this one. They represent the same thing, just like the fraction 1/3, is the same thing as 3/9. They just look different, right? But they represent the same thing. These equations of a line are exactly the same thing because I can multiply both sides by a number. So 2x plus 5y is 0, and that puts it in standard form. All right, let's crank along here because we have a few more that I want to do before we call it a day. And what we have for the next problem is this line now is going to go through the point 5, 0 with a slope of -2, right? So you know the slope and you know a point. So I have choices in what I can do here. So I'm going to say y minus y1 equals m times x minus x1 because I know a point that it goes through and I know the slope. So y minus the y value here is equal to the slope of -2 times x minus the x value of the point, 5. Let me multiply in here on the left. The 0 does nothing, so on the right it'll be -2x plus 10, because I'm multiplying in here, -2x plus 10. Now this is slope-intercept form. You could stop there and graph it or whatever you want, but I want it in standard form just because we're getting practice with it. So move the x term to the left by adding it. So you get a 2x plus y equals 10. We add 2x, so it disappears. We add 2x, and here you go. The leading term is not a fraction, and it's not a negative number. We have ax plus by is equal to c. This is standard form. And you're done. If you want to graph it, I wouldn't use standard form. I would use this form, the y-intercept form, because I know the y-intercept and I know the slope. I could graph it easily. All right, now we're going to jump into a little more challenging problems because now I'm going to tell you that the slope of this line is not a whole number, it's 1/2, so it's a fraction. And I'm also going to tell you that the y-intercept, b, is not a whole number, it's 3/2. Now this is not any more difficult than the other problems. You're given the slope and you're given the y-intercept, so I can write the equation of a line. But since you have fractions, you're going to have to manipulate the fractions when you start to put it into standard form. So let's see what we're talking about when it comes to this. We know the slope, we know the y-intercept, so I know I can write it in mx plus b form. So the slope will be 1/2 x plus b, which will be 3/2. Now if I just told you write the equation on the line and graph it, then I would just use this one and say I'm done. But I don't want to be done. I want to write it in standard form, and I want it to look, pretty, for lack of a better word. So I want it to get the x terms to the left by subtracting, so it would be -1/2 x plus y is equal to 3/2. Why did I do that? Because I want to subtract 1/2 x, it disappears, I subtract 1/2 x, so it pops on the other side. Now this is standard form, but it's ugly. It's ugly because I have a negative leading term, I don't really like that, and it's ugly because I have 1/2, and I don't really like to have fractions in these equations if I can help it, at least in a leading term. So let me rewrite it again, -1/2 x plus y equals 3/2. And let me ask you a question. What can I multiply this whole left side of the equation by to kill the negative and to kill the fraction here? Well, if I multiply by -2, the negatives will cancel, giving me positive, and the 2's will cancel, which means that basically I'll have nothing there on the leading term here. And so then if I do that, I'm going to have to multiply the right-hand side also by -2, because I have to multiply left and the right-hand side by the same thing. So if I do this, negative times negative gives me positive, 2's cancel, so the only thing left is x. Now when I multiply the -2 in here, it'll be -2 times y, and over here, what do I have? The 2's cancel, but the negative doesn't cancel with anything, so it's going to be negative, the 2's are gone, so it's just a 3. So what you have is x minus 2y is equal to -3. This is standard form in the proper way that you should write it. Now technically this is standard form also, ax plus by is c, and it's exactly equivalent with this as far as it represents the same line, but this one's just a lot prettier to look at. That's what you're going to be asked to give on a test. All right, how many more of these things we have? I think we only have one more maybe. Let's see here. One more, let's double check here. 2x plus, yeah, 10, only one more. And this is actually an important one. I'm not going to give it away. But it's a good one. Okay, so what we have is this point, or this line, goes through the following points. It goes through the point 3, comma, negative 2, and it goes through the point negative 2, comma, 3. So same sort of thing here. I don't have the slope, but I know I can find the slope because I'm given 2 points. And once I know the slope and I know one of the points it goes through, I can use the point-slope form to find the answer. So the first thing I need to do to make any progress is to calculate the slope. So let me do that first. The slope is delta y over delta x, which means I subtract the y values. Let me go this direction to this direction. So it'll be 3 minus the negative 2. And on the bottom, it'll be negative 2 minus the 3. Now I have addition on the top because this ends up becoming addition, so I have a 5 on the top, and on the bottom, negative 2 minus 3 gives me negative 5. When I divide these guys, I get negative 1, right? Negative 1 for the slope. So the slope is now known to be negative 1. Now, it was not given in my problem, but now I know what it is, and now I can use the point-slope form. Y minus y1 equals m times x minus x1. So y minus, I can pick any one of these points that I want to, as long as I know the slope and I know a point that it goes through. So let me pick the first one, negative 2 is equal to negative 1 times x minus, because I use this point, it's going to be 3. All right? And so let me make this an addition here, y plus 2, because of the double negative. Let me distribute the negative in, which would be negative x plus 3 by distributing into both of those there. And now I will just move this term over to the right-hand side by subtracting it. So y is going to be equal to negative x plus 1. Minus 2 gives me 0, minus 2 gives me 1. So I have y is equal to negative x plus 1. Now this is perfectly fine for the equation of the line, but I want it to be in standard form. So let me move the x over here by addition. And this looks like it's a good standard form version right here. X plus y is equal to 1. I add x to get rid of it. I add x. Here I have it in standard form. Now, just to drill it home one more time, I told you that whenever you know the slope and you know the point, a point the line goes through, you can write the equation. But we use this point just because we randomly just wanted to pick a point. But let's just do it again with this point to show you that you get exactly the same equation. So y minus y1 equals m times x minus x1. And then you have y minus y1, use this point, is equal to the same slope that we had, x minus x1, which is now negative 2, so let's wrap it in parentheses like this. So let's leave the left-hand side alone for now, and on the right-hand side, let's just say that it becomes x plus 2, because the double negatives do that. And then the next step, let's distribute the negative 1 in. Negative 1 times x is negative x. Negative 1 times 2 gives you this. And now let's add the 3 over. So what's going to happen over here when you have negative 2 plus 3? Negative 2 plus 3 is going to give you a 1. So the equation I got for the line in the slope-intercept form, negative x plus 1, is exactly the same as what I got here. So of course it's going to be the same standard form. These are the same thing. If you know the slope of the line, and you know any point, in which case in this problem I have was given 2 points, so I can use either one I want, you will get the same equation of the line. There is only one equation for any given line, and you can get to it by many, many different ways. That's what I'm trying to get at here. So I want you to get a sheet of paper and solve every one of these problems yourself. Make sure you understand them. We're going to get a little more practice with doing these types of problems in the next lesson. The only difference will be that as we solve some of these next problems, we will have more fractions involved. We will have slightly more complicated manipulations when we have to add fractions, and it just kind of introduces more chances for error. But the exact same process is going to be applied to all of these problems exactly as we've done here. So make sure you can solve these. Follow me on, and we'll get practice with writing equations of lines in algebra.